Assalamualaikum and hi everyone, and welcome to this video presentation on smart energy and climate monitoring for tomato cultivation. We are excited to take you through a modern approach to growing tomatoes using smart agricultural technologies. This talk is inspired by a fascinating video that showcases a real-world smart greenhouses setup, and I'll be using that as the backbone of our discussion. But rather than just describing what's in the video, my goal is to break it down and explain how and why this system works, and most importantly, how they can improve tomato farming both economically and environmentally. Now, we all know that tomatoes are one of the most common and economically important crops around the world, but they are also incredibly sensitive to environmental conditions, meaning that even small shift in temperature or humidity can have a big impact on the quality and quantity of the harvest. That's where smart energy and climate monitoring comes in. By using IoT, Internet of Things, or BESS system, we can keep the growing conditions optimized at all times. This isn't just about fancy tech, but it's about achieving better yields, reducing waste, and promoting sustainable farming practices. There are four presenters to talk about these technologies. They are Muhammad Rizwan, Muhammad Khairul bin Hasmadi, Akmal Kuzairi bin Muhammad Sani, and me, Muhammad Irfan bin Idris. Now, here's a quick overview of what we are aiming to accomplish during this presentation. First, we will explore why climate and energy management is essential for tomato plants. This will include looking at optimal environmental conditions and the risks when those conditions aren't met. Second, we'll dig into how IoT system works in agriculture, especially in greenhouses. We will talk about how data from sensors is collected, processed, and used to control systems like fans, lights, and irrigation units. And finally, I will guide you through some of the practical steps involved in implementing a smart monitoring system and share some typical outcomes, including improvement in yield, energy efficiency, and crop quality. Now, let's start with the why. And why does it matter so much to control climate and energy when growing tomatoes? Tomatoes are high value, high input crop. They have very specific environmental needs. First one, during the day, temperatures should be kept between 20 to 25 degrees Celsius. Second, at night, slightly cooler in between 15 to 18 degrees Celsius is ideal. The last one is, when it comes to humidity, you are looking for a range between 60 to 70%. Too hot, and you run into problems like reduced pollination and the pollen become less viable and fruits don't set properly. Too much moisture, and you get fungal diseases like powdery mildew or botrytis. Not enough water at the right times, and you can develop blossom end rot, which is when the bottom of the tomato turns black and is soft due to calcium imbalance and often caused by inconsistent irrigation. All of these issues led to lower yields, poor fruit quality, and higher production costs. Now, here's the other side of the equation for energy use. Maintaining a stable environmental inside a greenhouse requires a lot of power. You need heating system to keep the temperature up during cooler nights, ventilation fans to move hot air out on sunny days, LED grows lights to supplement light during cloudy weather or short days, and water pumps for regular and accurate irrigation or fertigation. And if the system aren't optimized, you end up wasting energy, overwatering, or stressing the plants. That's where smart monitoring comes in, and it lets us measure exactly what the crop needs in real time and adjust system only when necessary. That leads to healthier plants, lower resource consumption, and ultimately better harvest.
This project is designed to measure, records, control and optimize greenhouse indoor environment while proportionally reducing energy consumption. The device was installed and tested in a 100 by 20 meter square greenhouse located in University Putra, Malaysia, Serdang, placed at the main incoming power line. greenhouse monitoring system box is a smart monitoring and control box wherein a few monitoring sensors are integrated with the ESP32 microcontroller in order to give a reading of the sensors and stimulate the controlling system that improves the climate conditions of the greenhouse system. In this box, there is a Node MCU ESP32 microcontroller that integrated with sensors such as DHT22, temperature and humidity sensor, GY30, light intensity sensor, MG811, CO2 sensor, and soil moisture sensor. The display components used in this box are DPM, digital power meter, and 20x4 LCD display to display monitoring information and energy used. As in controlling mechanism, we connected ESP32 microcontroller to relays that connected to the water pump, axial fan as well as exhaust fan and making the necessary adjustment to optimize the greenhouse indoor temperature and soil moisture. ESP32 has built-in Wi-Fi that connected to the internet. All the data from this microcontroller are sent to the GMS web server and can be accessed through smartphone or computer.
Now, let's zoom in on the system itself for what does a smart monitoring setup actually look like in a greenhouse. Based on the video, we can identify three main components. First one is sensors. These are placed throughout the greenhouse and constantly collect environmental data. For sensor, this has four types of sensor, which is the first one is temperature sensor for air and soil, humidity sensor to track moisture levels in the air, light sensors to measure sunlight intensity, carbon dioxide sensors in some advanced setup, and soil moisture sensor, which are critical for irrigation control. The second one is controller or hub. This is the brain of the system. It collects all the sensor data and makes decisions based on predefined threshold. For example, if the temperature exceeds 28 degrees Celsius, it knows to activate the exhaust fan. If the light level drops below a certain point, it turns on the light grow lights. The third one and the last one is actuators. These are the physical devices that respond to the controller's instruction. For example, fans for cooling, heaters for warming, LEDs for lighting, water pumps for irrigation or misting system. So you have this seamless loop. First is sensing, second one is deciding, and the last is acting. It's all automated. And most systems also come with a dashboard, either on a touchscreen or even on a mobile app where you can monitor conditions, see alert, and make manual adjustment if needed. In a way, it's like giving your greenhouse a nervous system and brain where it can feel what's happening and respond instantly. This is what makes smart farming not only possible, but efficient, sustainable, and scalable.
Now, let's dive into one of the most important parts of this system. The step-by-step breakdown of the components that make smart monitoring and climate control in tomato nursery is possible. First component is sensor, which is the eyes and ears of the system. These are placed strategically throughout the greenhouse or nursery to monitor the real-time environmental conditions. We commonly use sensor for air temperature, humidity, soil moisture, carbon levels, and light intensity. For example, if the humidity drops too low, the humidity sensor immediately detects that change. Similarly, the soil moisture sensor tells us when the roots need water, and the carbon sensor help optimize the photosynthesis, which is vital for tomato yield and quality. Second is the controller unit, the brain of the operation. This is the brain of the system. This could be a microcontroller like an Arduino or a more advanced setup like a Raspberry Pi and industrial PLC. Its job is to collect all the data from the sensor, analyze it, and then make smart decisions based on the data. So, for instance, if the temperature exceeds 30 degrees Celsius, the controller activates the exhaust fans or opens the greenhouse vents. It's fully automated, no human needed to press any buttons. And then that is actuator. which is the hands that take the action. Now, once a decision is made by the controller, the actuator carry it out. These are the parts of the system that physically change the environment. This includes the device like fans, irrigation system, mist sprayers, heaters, grow lights, or even automated windows. So if the controller senses dry soil, it activates the irrigation line automatically. If it's too dark inside the greenhouse, grow lights are switched on to maintain ideal light levels for healthy tomato development. Then fourth is the power and connectivity, which is the backbone. The system needs power and a way to communicate. Power usually comes from either direct electricity or solar panels, especially in rural areas or for sustainability purpose. Connectivity is handled via Wi-Fi or GSM module. This allows the data to be sent to a cloud dashboard or mobile app so that you, as the grower or the farmer, can monitor everything from anywhere in the world, even if you are not physically in the nursery. So, in summary, we have four main parts: sensor, collect data, the controller, analyze it, the actuator, respond automatically, and power plus connectivity to ensure everything runs smooth and remotely. Together, these components form an intelligent ecosystem that keeps your tomato nursery optimized 24/7 hours with less labor, more precision, and better yield. Let's now explore a critical function that truly transforms a traditional tomato nursery into a smart automated system, and that's data collection and cloud integration. This is the part of the system that allows growers to monitor, manage, and optimize the nursery environment remotely and efficiently, all using real-time data. First, data collection from sensor. The system starts by collecting data from various environmental sensors installed in the nursery. For example, soil moisture sensor tell us how much water is available to the roots. Then, temperature and humidity sensor measure the air conditions that directly affect the tomato growth. And then, light sensor monitor the intensity and duration of sunlight. Some systems also use CO2 sensor to manage the photosynthesis level. These sensors take readings at intervals, say, every 30 seconds to 5 minutes, and send this raw data to the system processing unit. Next is the processing by the controller unit, which is local decision making. All data sensor is routed to a microcontroller like ESP32, Arduino, or Raspberry Pi. Think of this as the local brain. Here, two things happen. First, local analysis. The controller checks if any values exceed thresholds. For example, if the soil is too dry, it can immediately activate the irrigation pump. Second, the data packaging. It formats the sensor readings for transmission to the cloud platform. So, even before the cloud gets involved, the system already starts responding to urgent needs like heat spikes or soil dryness automatically. And then third is the cloud integration via internet connectivity. This is the process data is sent to the cloud using Wi-Fi or GSM, like a SIM card or for IoT. This is where things become truly smart and remote accessible. The data is uploaded to cloud platforms such as Blink, Thingsbot, Firebase, or custom IoT dashboard, which is custom from the farmer. This platform store all your historical data, offer visualization through graph and gauge, issue notification or alert based on specific rules. And then next, fourth is farmer dashboard, real-time remote monitoring. From the cloud, data becomes accessible on your device, whether it's your phone, tablet, or PC. The dashboard gives you a live snapshot of current condition. For example, soil moisture is 24%, the humidity is 60%, and the graph showing trends over hours, days, or weeks to the farmer. And then notification like temperature exceed 35 degrees Celsius or irrigation disactivate. Remote control features, for example, if the app tells you moisture is too low, you can tap a button to irrigate instantly to flow the water. This means you can manage your nursery anywhere, anytime, whether you are on the farm, at home, or even in another country. And then we must see the importance of cloud integration in tomato nursery. Why is this integration so powerful for tomato growers? Because tomatoes are very sensitive to sudden humidity change, soil water stress, heat stress above 32 degrees Celsius. Without timely intervention, growth slows, and then diseases like blossom and rot appear and yields drop. Growth monitoring ensures you are never out of the loop, and it enhances to decision making using historical data. And then efficiency by reducing labor and water waste, and sustainability through precision resource use. So, in simple terms, data collection and cloud integration give the nursery a digital brain and nervous system, sensing, responding, and communicating with you in real time, and it brings smart farming from theory to practice. Let's move on to the heart of automation, which is the automated control system. In a smart tomato nursery, this system doesn't just collect the data, it also takes the real-time action based on that data to keep the environment ideal for tomato seedling growth. What is an automated control system? This system like a digital farm assistant. It monitors the conditions, processes the sensor inputs, and automatically control devices like irrigation pumps, fence misters, and grow lights. All of this is done using program logic in a microcontroller like an Arduino or ESP32, making the nursery semi-autonomous. Tomato nursery example: soil moisture automation. For instance, take tomato seedlings, which are very sensitive to overwatering or underwatering during their early stage. Let's say the soil moisture sensor detects that the soil moisture level has dropped below 30%. This triggers the control system to turn on the irrigation pump, delivering precise water through a drip system. And then once the soil moisture reaches the optimal level, for example 45%, the pump turns off automatically. This prevents stress on the roots and helps avoid disease like damping off, which is very common in wet nursery bed. Tomato temperature control example, tomatoes are also heat sensitive during the germination and seedling stage. If the internal greenhouse temperature goes beyond 32 degrees Celsius, the control system activates exhaust fans or opens the ventilation flaps to reduce heat build-up. If the temperature falls too low at night, let's say below 80 degrees Celsius, the system can trigger heating mats or a greenhouse heater, ensuring a stable microclimate that supports the healthy tomato growth. Next, the humidity and mist control. Humidity is another critical factor tomato nursery. If it drops below 50%, the controller can automatically start a fine misting system, raising the humidity to an optimal level. This prevents leaf curling and supports proper transpiration. Next is light control for tomato growth. On cloudy days or during early morning hours when light intensity falls below the required 200 meter per second, LED grow light can turn on automatically, ensuring the seedlings still get the required daily light to exposure for uniform development. and then the manual override and remote access. What makes this even more powerful is that the system includes a mobile app interface. So even though it's automated, you can manually turn pump or fans on or off from your phone, especially useful during system checks or unexpected weather events. So the benefits to tomato nursery is tomato seedling thrive in tightly controlled environments, and then automation helps you maintain the uniform soil moisture and avoid the heat stress during the hot midday periods, prevent root disease caused by excess water, ensure the consistent light, temperature, and humidity for uniform seedling development. All of this leads to healthier seedlings, healthier transplant, and survival rates, and ultimately better yields in the field. So, in short, the automated control system turns your tomato nursery into a self-regulating environment like cruise control for your crops, giving you peace of mind and consistent seedling performance.
Okay, let's now move into the energy monitoring and management system of the smart nursery, which plays a vital role in maintaining operational efficiency and sustainability. First, energy usage is continuously tracked using smart meters that are integrated directly into the controller systems. These meters measure real-time electricity consumption of various devices such as fans, heaters, pump, and lighting systems. The data is then logged and visualized through an energy dashboard. This graph, taken from the video demonstration, shows how energy usage varies throughout the day. You can clearly see peaks during active hours and dips during off-peak times, allowing operators to identify high consumption periods and adjust accordingly. Three key energy saving strategies are employed here. First, cyclic operation. Cyclic operation is instead of running devices continuously, the system cycles them based on set thresholds and feedback from sensors, minimizing energy waste. Second is off-peak scheduling. Energy-intensive tasks like water pumping or lighting supplementation are shifted to off-peak hours when electricity tariffs are lower. And third is solar coordination. The system is capable of syncing operations with solar energy availability. For example, running irrigation pumps during periods of high solar output reduces reliance on the grid. These strategies not only lower operational costs, but also align with sustainable practices. In fact, the video showed how smart energy tracking enables the integration of renewable sources like solar, further improving the facility's carbon footprint. Let's take a closer look at a case study featured in the video, which offers a compelling real-world example of how smart nursery management systems can transform greenhouse operation. The greenhouse highlighted in the video was located in a temperate climate region where weather conditions fluctuate significantly between seasons. The facility spans approximately 1,000 square meters, a size typical for medium-scale commercial nurseries. It was equipped with a fully integrated smart control system consisting of sensors, actuators, climate modules, energy meters, and a centralized interface that enables real-time monitoring and decision-making. One of the standout features demonstrated was the system's ability to maintain climate stability. A combination
of smart automation tools such as automated ventilation flaps, rectable shading systems, high-pressure misting nozzles, and efficient electric heating units was developed and controlled based on continuous sensors feedback. These tools work together to respond dynamically to changing internal and external conditions. What was truly impressive was the consistency achieved. The temperature inside the greenhouse was maintained within a very narrow range, fluctuating no more than +1 Celsius from the desired set point. This level of precision is crucial for sensitive crops like seedlings and ornamentals, which can be significantly affected by even small temperature changes. From an energy standpoint, the system showcased significant efficiency improvements thanks to predictive control algorithms of peak energy usage scheduling and partial reliance on solar energy. The greenhouse was able to reduce its overall energy consumption by approximately 20 to 30% compared to a similar non-automated setup. For growers, this translates to tangible cost savings on electricity bills, especially in operations that run 24/7. But the benefit didn't stop at operational efficiency. The controlled environment also led to healthier plants with improved growth rates. Reduced temperature stress meant that crops grew in more consistent and favorable conditions, leading to better root development, uniform growth, and even reduced pest susceptibility. Over time, this kind of performance contributes to higher yields and better quality produce. This case study really illustrates the full value proposition of smart nursery systems. Not only do they cut down energy and use costs, but they also optimize growing conditions to improve crop quality, boost productivity, and create a more sustainability and resilient agriculture model. In short, this real-world application highlights how technology can be a game changer for modern nurseries, providing both environmental and economic advantages. Let's touch on the user experience, which is one of the most crucial parts of any smart system. The system provides a mobile and web dashboard interface that is both user-friendly and comprehensive. Users can monitor real-time data such as temperature, humidity, and energy consumption. Alerts are sent instantly if something deviates from optimal conditions, like a temperature spike or a pump failure. First, the user logs in with secure credential. Second, they are greeted with a live view of sensor data and status indicators. Third, the dashboard provides graphical trends of key metrics over time, making it easy to spot patterns. And lastly, if something needs immediate attention, the user can perform manual overrides, such as turning on a fan or closing a vent with just a tap. What stands out is the human-centered design. The layout is intuitive with clear icons, color-coded alerts, and responsive design for phones and tablets. This ensures that even users with minimal technical background can operate the system confidently. So, overall, this interface bridges the gap between advanced technology and everyday usability, empowering users to take control of their environment with ease.
So next, we move to the challenge and consideration. As much as there are numerous benefits of smart energy and climate system to the tomato nurseries, it is noteworthy that there are some challenges attached to the implementation of such technology.
the initial setup cost may be huge, farmers should spend money on IoT sensor, smart controller, data loggers, and even renewable energy sources such as solar panels. These costs may not be profitable in the short term provided they save valuable resource and provide improved yields, but the initial cost might not be affordable, particularly when one is dealing at a small scale level. The one important issue is the technical knowledge required. Growers are required to acquire knowledge and how to install the system, troubleshoot and operate the system. They have to be able to read sensor data, make adjustments and react when the system identifies a problem. This implies that they need to have training programs and user manual which are accessible. It is also advisable to do calibration and maintenance regularly. As an instance, sensor to measure soil moisture on air temperature will have to be cleaned and calibrated after a certain period, so as to ensure that they are accurate. When the sensor delivers inaccurate information, there may be a case of over or under irrigation. This kills the plants and wastes resources. Then, there is the danger of either out of connectivity or power. A IoT of intelligent system operates using Wi-Fi or cellular network to send information. The monitoring in remote farming areas may be affected by lack of good internet access to provide real-time monitoring. Similarly, the system could be shut down as a result of power failure unless provision has been made on backup facilities, such as off-grid energy as in solar system. Finally, growers should consider the local support and spare part. When a sensor is faulty or unupdated of the software is required, it is essential that there is ease in accessing the replacement parts and technical service. Lack of local expertise might end up in inordinately large problems disrupting the operation of the farms. As early as possible, farmers, suppliers, and policymakers should become aware of such obstacles so that farmer training, local technical support, and reduced financing rates can be planned as ways to make more growers successfully changes over to smart system. Next, we move to the future prospect. The opportunities of intelligent energy and climate management in tomato production are actually thrilling. When looking ahead, improvements in artificial intelligence (AI) can render such systems more intelligent and flexible. As an example, years of farm data can be analyzed to be able to determine the required amounts of water that the tomato plants need in various stages of growth through AI. It can even program when irrigation should be done without the need to go there. Therefore, it saves you a lot of times and have good moisture period in the soil. The next big thing is the integration with hyperlocal weather forecast. By integrating IoT system with real-time weather information, the body can predict rain, heat wave or cold snap and monitor ventilation or shadings or irrigation in advance. This accuracy minimizes stress to crops and makes the most of the crop. More advanced data analytics will be also involved. The farmers can use dashboard of long-term changes in climate conditions, long-term soil health, and pest threats. This information may guide them to make sound management decisions and plan the season ahead. The second notable occurrence is the use of renewable energy to establish such systems, such as devices as solar panel, in turn could offer a clean energy supply to the power pumps, sensors, and controllers. This decreases dependence on the grid, decreases the cost of electricity, and advances sustainability targets. Mobile apps-based remote monitoring is also becoming more user-friendly. In case of too much moisture being lost in the soil or sensor identifies an issues in the greenhouse. The farmers are able to get an alert on their phones. This implies that they will be able to respond in time even when they are not on the farm. The combination of all these novelties, such as AI, integration of the weather, renewable energy, and mobile connectivity, will make smart nurseries more resilient, affordable, and practical, even though growers of any size. They will assist farmers to grow high-yield tomatoes at lower cost, using fewer resources and less of greenhouse effect. Last but not least, we move to the conclusion. In conclusion, it would be beneficial to summarize major points we have discussed regarding smart energy and climate system of tomato growing. First, the tomatoes are an ideal crop to use on the technology, as tomatoes are easily affected by the temperature, humidity, and water level. That is, the factors can be managed quite well such that the resulting growth rates, quality of fruits, and total output will be enhanced. With the ability to monitor the conditions in real time and adjust quickly and intelligently, nursery managers and farmers can use IoT device and automation. To illustrate the skills of the latter, say when the moisture of the soil lowers beyond a specific limit, the system may turn on the irrigation automatically, thus preventing the stress of the plants, and it saves the labor. Automated irrigation tower is particularly influential because it is capable of reducing water waste, which is essential since water supply dwindles. It has been demonstrated that precision irrigation has been able to achieve a water savings of up to 30% over conventional techniques, and it enhances plants' health and crop productivity. They also cut emissions of carbon and decrease the cost of operation when operated by renewable sources of energy, such as solar panels. These do not only make them environmentally friendly, but also cheaper in the long term. Combination of these technologies can make tomato nurseries more sustainable, scalable, and more resilient against the climate issues. It assists farmers to respond to altering climatic conditions, minimize risks, and tackle rising market pressure on the high standard of products. Well-trained local operators access to local support and pocket-friendly financing could turn smart nurseries into the game changers of tomato production for both smaller scale and large commercial growers. Your investment in the solutions made now will create a brighter, greener, smarter agriculture that takes better care of our farms, our food, and our planet. Thank you, and we wish this presentation will give you some ideas of how smart energy and climate technologies can transform tomato cultivation to another level. And goodbye.